Welcome back. We're going to be talking about like radicals, and like radicals is a lot like looking at like terms. With like radicals, you have to have the same index, but you also have to have the same radicand. So when we're talking about like radicals, we're going to be talking about adding and subtracting these guys. Remember, multiplication is great because it doesn't care who you are, if you're like or not, you just put them together and we're happy. Like radicals are like terms. You have to have pieces that match each other, right? Now, we've done like things before. If I were to say, what's 5x plus 3x, what would you tell me? You would say 8x because you see that this guy has x, that guy has just x as well, so altogether you would have 8 of those x's, right? Even if things looked uglier, and I said 5x to the third y plus 3x to the third y, are these guys like terms? Yes, they are. They both contain matching variable components with the x to the third y. So altogether we would have 8 x to the third y. You guys with me on that? So you guys understand what like terms are, right? Even when like terms get a little crazy.
Really?
Oh, yeah.
Yeah. My face.
Why are you looking at me that way?
Getting confused.
So 5
8
Ryan
people.
Craigs plus 3 Ryan Craigs equals 8 Ryan Craigs?
No.
I haven't looked like this in about 15 years, all right? That's how I looked when my wife met me. Now I look more like this.
Oh, big difference. I mean, amazing.
Oh, well, the arm muscles haven't changed though. So when I combine this, I get 8 stick people, right? Now you got to be careful though, because if I had this guy and if this was that, would these guys be like terms?
No, but that's a girl, Craig.
A girl Craig.
That's your wife, isn't it?
That'd be a horrible
She's
party.
Mrs. Craig.
Yeah, you know what? She's never gonna watch this video, so I can say all kinds of things I want to about her.
But you won't.
I would only say nice, positive things. So if you guys get that, and you see how stick person, still stick person, right? Did the stick person change?
Nope.
Coefficient did, right? Because you were combining like stick people.
Yes.
Well, what if I were to say this then? 5 square roots of yawn plus 3 square roots of yawn equals what?
A lot of yawns.
Isn't that 8? And when you just say 8 square roots of 3? Because notice these guys are both square roots of 3. They're matching pieces, and so you're going to end up with the square root of 3 at the end. Do you agree with that? Or did I just blow your mind?
So the thing stays the same inside the radical.
The radicand, the thing is called the radicand, stays the same. Don't you roll your eyes at me. The radicand and the index stays exactly the same, right? Did I change anything with these exponents up here? With these examples, did I change exponents? It stayed exactly the same, right? The variables didn't change. The exponents didn't change. Likewise here. Okay? They're going to stay the same. Bless you.
Well, you know what I'm going to ask then.
Actually, I don't. Should I be scared?
No.
Good.
I
'Cause I'm
was
not.
just going to say, just like the same thing we just did, we're going to still apply that same rule.
Well, there's not a rule, there's not a product rule or quotient rule here. If this guy could have been simplified, then we would.
Okay.
Well, let's look at this. What's 7 square roots of 2 plus 11 square roots of 2? Maybe the easiest problem today. 7 plus 11 is 18 square roots of 2. You don't change the radical part. These guys are both square roots of 2, so I combine those and I get 18 square roots of 2. Yes?
Okay.
Well, if we're okay with that, then we should be okay with this one. 6 square roots of 5 plus 7 square roots of 3 minus 10 square roots of 5 minus 13 square roots of 3.
And there it is. That's what I was trying to figure out.
Do we have like radicals to combine here?
Yes.
We do. Now keep in mind that if we were combining variables and I had some that had x and some that were y's, you wouldn't combine x and y together because they're not like radicals or like terms. Here, I've got square root of 5 and square root of 5. How much of the square root of 5 do I have?
-4.
I get -4 square roots of 5. That stay the same, right? Okay. Well, what if I look at the square roots of 3? I've got 7 square roots of 3 and minus 13 square roots of 3. What is that?
6.
-6. Notice that the square root of 3 doesn't change. It's still the square root of 3. What do you think? I would love to see that on a quiz next time. Yep, you would. Are you going to try to combine these guys?
Well, I was just about to say that.
Are they like terms?
No.
Oh, okay.
If I were to say this, if I had -4x minus 6y, would you combine those? No, because they're not like terms.
Yeah, but didn't we just get through doing something like that?
We were using multiplication. If we were multiplying the square root of 5 times the square root of 3, we could combine those guys through multiplication. But remember, addition is kind of a racist. Okay? If you don't look the same, you don't go together. That's how addition is. Multiplication's like, man, we're all the same. We're all brothers and sisters.
Adding and subtracting, we're not going to combine.
Right, he's a mathematical racist. Who's that tapping at my door in the middle of a recording session?
Edgar Allan Poe is at your door.
If he's at my door, well,
He's going to run, or what you going to do?
I don't know.
Because he should be alive.
He shouldn't be. That was a creepy dude. You read his stories? Creepy
It was
dude.
awesome.
Who?
Edgar Allan Poe?
Oh.
You know, Mary's 13-year-old cousin.
Well, they all was in the insect.
You know what? It's okay. Now we've gotten off topic here. Let's look at this one right here. Let's find the like radicals. So all the radicals are alike, right? No. What do you mean no?
The radicands are all alike.
These guys are cube roots, but the radicands are all the same. But I said to be like radicals, same index and same radicand, so only these pieces right here are alike, and what do we get?
7
I was going to come up with -12
Oh, 21.
cube roots of 2.
Oh, that's a 2. I thought that was a 2.
It does look like
Jeez, Mr.
Oh, it's 21.
That's 21.
See, we're all looking.
I'm starting to think it's
I thought it
a
was a 2. I thought it
That's
was
a 2 and a 1.
Well, your one's been like a little bit there.
You gotta make it a little more pronounced.
Oh, okay.
There you
There
go.
you go.
Look at.
Side nose.
We're a strange class.
You are a strange